Space curiosity. A solar flare is a powerful burst of radiation from the Sun that can affect the Earth's atmosphere and cause disturbances in radio and magnetic signals. According to NASA, solar flares are associated with sunspots and the release of magnetic energy in the Sun's atmosphere. They can last from minutes to hours and emit light and particles across the electromagnetic spectrum. According to Wikipedia, solar flares vary in frequency and intensity depending on the 11-year solar cycle. They are also related to other solar phenomena such as coronal mass ejections and solar particle events. Solar flares are fascinating and beautiful events that reveal the dynamic nature of our star. Solar flares can affect the Earth in various ways, depending on their intensity and frequency. Some of the effects are: 1. Radio and satellite communication disruptions. Solar flares can temporarily alter the upper atmosphere, creating disruptions with signal transmission from, say, a GPS satellite to Earth, causing it to be off by many yards. 1. This can interfere with short-wave radio communications, which rely on bouncing signals from charged gases in the ionosphere layer. 2. Power grid disturbances. Solar flares are sometimes accompanied by a coronal mass ejection, CME for short. 2. CMEs are huge bubbles of radiation and particles from the Sun. 2. They explode into space at very high speed when the Sun's magnetic field lines suddenly reorganize. 3. When particularly strong, a CME can also interfere in power utility grids, which at their worst can cause electricity shortages and power outages. 3. Auroras. When charged particles from a CME reach areas near Earth, they can trigger intense lights in the sky, called auroras. 3. Auroras are usually seen near the poles, where the Earth's magnetic field is weaker and more particles can enter. 3. Auroras are beautiful and harmless phenomena that reveal the interaction between the Sun and the Earth. 4. Radiation hazards. Solar flares release a lot of radiation into space. 4. If a solar flare is very intense, the radiation it releases can pose a threat to astronauts and spacecrafts in orbit. 4. The radiation can also increase the risk of skin cancer for passengers and crew members on high-altitude flights, especially over the poles where the Earth's magnetic field is weaker. 4. These are some of the ways that solar flares can affect our planet and our lives. The biggest solar flare ever recorded was a massive X-28 Plus class flare that occurred on November 4, 2003. This flare was so powerful that it overloaded the sensors of the satellite that measured it, and some experts believe it could have been even stronger than X-281. This flare was part of a series of intense solar storms that erupted from a large sunspot group on the Sun's surface. The flare emitted a huge amount of radiation and particles that reached the Earth and caused geomagnetic disturbances, auroras, and radio blackouts. 12. The flare was also accompanied by a coronal mass ejection, CME, which is a massive explosion of plasma and magnetic fields from the Sun's atmosphere. The CME traveled at a speed of about 2,000 km per second and reached the Earth in about 19 hours. 1. The CME also triggered a solar proton event, SPE, which is a surge of high-energy protons that can pose a radiation hazard to astronauts and spacecrafts. 2. The X-28 Plus flare of 2003 was the largest solar flare in recorded history, but it was not the only one that had a significant impact on Earth. There have been other solar flares that have caused geomagnetic storms, communication disruptions, power outages, and other effects on our planet and technology. Some examples are: 1. The Carrington event of 1859. This was a powerful solar storm that caused widespread auroras, telegraph failures, and fires around the world. 1. It is considered to be the most severe geomagnetic storm in recorded history. 2. The March 1989 storm. This was a geomagnetic storm that caused a blackout in Quebec, Canada, affecting 6 million people for 9 hours. 2. It also damaged transformers and power grids in other parts of North America and Europe. 3. The Halloween storms of 2003. These were a series of solar storms that occurred around the same time as the X-28 Plus flare. 3. They caused satellite malfunctions, GPS errors, radio blackouts, and increased radiation levels in aircrafts. 4. The July 2012 storm. This was a massive CME that missed the Earth by a narrow margin. 4. If it had hit us, it could have caused widespread damage to power grids, satellites, and communication systems. 4. It is estimated that it could have cost up to $2.6 trillion in economic losses. These are some of the examples of how solar flares can affect our planet and our lives. If you want to learn more about solar flares, a solar flare and a CME are both types of explosions that occur on the Sun, but they have different characteristics and effects. According to EarthSky 1, a solar flare is a flash of light on a small portion of the Sun, while a CME is a cloud of magnetized particles that is ejected from the Sun's atmosphere. The strongest flares are usually accompanied by CMEs, but not all CMEs produce flares. A solar flare releases a large amount of energy, while a CME can travel through space and hit the Earth's magnetosphere, causing geomagnetic storms. 1. Some of the differences between a solar flare and a CME are: 1. Appearance. Flares look like bright flashes of light on the Sun. 1. CMEs look like clouds zooming out into space. 2. Speed. Flares travel at the speed of light and reach Earth in 8 minutes. 2. CMEs travel over 1,000,000 miles per hour and take up to 3 days to reach Earth. 2. 3. Effects. Flares can disrupt radio and satellite communications, GPS signals, and high-frequency radio waves. 3. CMEs can cause auroras, power grid disturbances, radiation hazards, and satellite malfunctions. 12. These are some of the differences between a solar flare and a CME. Thanks for watching this video. If you enjoyed watching this video, please like and subscribe this. Thanks for watching.